Hi, welcome to this project. In this project, I'm going to use TensorFlow library to apply this wonderful library to build a deep neural network model to solve a business problem. The dataset that we have today is Apple Music. This dataset is a real dataset and is coming from Apple Music user interaction in 2023. The problem that we are going to solve is how possible a user is coming back to the Apple Music application to renew the subscription. Before doing anything, let's just take a look at the data. We have a CSV file, as you can see here. Column A is just a user ID. It is just the identification. Column B and column C are talking about how many minutes that user was listening to the music. Column B is the overall minute for the listening to the music, and column C is just the average. For example, row number 1, just because that user only purchased one music, the average and sum is the same. Column D is just the overall price that a user spent for purchasing the music, and column E is the average. The interpretation for column D and E is the same as column B and C. Column F is about that specific user rated the music or leave a review or not. If they left a review, we will have a label as a 1, otherwise this is 0. Column G is just which rate that user applied. If you see for some rows that in column F we have 0, we have some rate in column G. Just because for those people didn't leave any comment, we couldn't leave them as a null value. So in column G, I just put the average number. You can apply the sum and any other techniques for dealing with the null values. I use the average. However, I know putting the constant value might change the distribution, but purpose of this project is not dealing with null values. There are a bunch of ways for dealing with null values, so many sophisticated models. For this particular project, I just use the simplest one to deal with the null values. Column H is that user, how many supporting ticket that user sent. And column I is how many days the customer has been using the services. It's just a lifetime, just a tenor. And column J is the target. How possible the user is coming back and renew the purchase. One is that this customer previously come back to the Apple Music and renewed the subscription, and 0 means that user never come back. So the problem is that we are going to build a machine learning to make sure which customer the Apple company should focus on those ones to send advertisement, a campaign, or these kind of things to those people who are probably coming back, not those ones the target is 0. Okay, this is just a data set. Now let's go to the code in Python. Okay, as I said, the title of this project is Apple Music Business Case, and we are going to apply deep neural network with help of TensorFlow library. So first of all, we should know what is the problem. Before doing any project, such as data analysis, statistical, A/B testing, machine learning, or even very, very basic queries, we should know what we are looking for. So in this project, we should first know what is the problem. The problem is that we have a dataset for Apple Music application user. Each user in the dataset that I just showed you purchased at least once. This is the preliminary step for being in a dataset. So we want to create a machine learning algorithm based on our available data. The available data means in a real world, you might create very sophisticated model as long as you have data. But if you don't have too much data, you have to deal with this condition. How do I know? Just a bit, we can do data augmentation to add some synthesized data, but we need real data to make the best model. So if we don't have too much data, we need to just handle this situation. Building a machine learning is not just going through code cell by cell in a notebook or in the environment or in the ML platform. We need to deal with these conditions. We need to do some engineering in the process. So the main idea is that if a user has low probability of coming back, there is no reason to spend any money or advertising. So the company are just looking for the users that the target is 1. These are the customer probably come back again and purchase from the company. So they are looking for a model to say this customer is 1 or 0. If it is 0, they don't want to spend anything on that customer. If it is 1, that's amazing. They would like to send some advertisement or campaign to that customer. Okay, this is the business problem, and now we are familiar what we are looking for in this project. Now it's time to get familiar with the data. However, previously I showed you the data. It was just eyeballing, but let's go into detail of the columns. In the dataset that I just showed you, we have customer ID. This is just a label. I can say this is just a label. And for those ones, they are, all of them are as an input for this project. And the last one is the targets. This is our targets for our project. This is target. So we have label. We don't need it at all. We should remove it because this is just a label and it doesn't bring any impact on the model. From overall music lengths to tenor, they are all inputs. And the target is just a target, and we are looking for to find the number for this column. Okay, now it's time to do data preprocessing. Just because we are dealing with the real data, it's not just the toy data or some data that you can find, just for education or university. We need to do some data preprocessing on data. In a real world project, we need to deal with the data preprocessing because data is not as clean as we expected. We should tackle this condition. So we are going to go step by step. Number 1 is that we need to extract data from the CSV file. It means we need to import the data in a CSV file with a Python code or environment. So the first thing is that I need to use a library in Python to extract the data. I use NumPy because NumPy is very, very popular and powerful library for dealing with numerical data format. If you remember the dataset that I just showed you, we don't have any string. all the data that we have are number, even though one of them is label. It is number. It's a kind of number. However, we can remove it later. I import the NumPy and the library. After that, this is just a path that I stored the file. And then I use the NumPy load text. Load text in NumPy can import anything based on the format. The first argument is the path that is related to the path that we just defined previously. The delimiter is comma. Why comma? Because this is the CSV format. And as you know, the CSV format, the data is separated based on a comma. And skip rows should be 1. Why? Because if I don't put skip rows, the first row in the CSV file is a string, and NumPy cannot understand the string. So we should skip the first row, and after that, all the data that we have, all of them are number, and NumPy has no problem. So it can read the data. We store the data in an object or variable as a raw CSV data. Now the data is stored in Python, so we can go to the next step. In the next step, we should say which column or columns we don't need it. As I said, just because user ID is just a label, we don't need it at all. We should drop it because it can't be helpful for the project. We create another variable as an unscaled input all. And I brought the raw CSV data that we just created and put all data on that. But I said, I need to slice this data set. I said, I need all the rows. But in terms of the column, I need the columns after column 1 until the first last column. This is all the input data. I don't need the first column because this is the label, and I don't need the last column because this is just a target. Any columns between these, they are my input, and I store all of them as an unscaled input all. And I said unscaled because they are not scaled yet. Preprocessing and scaling is very, very important step when we are gonna build a deep learning neural network. And we see the data is here just as an array. Why array? Because we are using NumPy and not pandas. If we use pandas, they are gonna be data frame. But TensorFlow is not, in a good relationship with the data frame, and NumPy is the best friend for the TensorFlow. So the target just was the last column, and now the data set is very, very organized. This is just the input data. What about the targets? We store all the input data, not the first, not the last, anything between them. What about the target? For target, very easy. I need all the rows for the raw CSV data, but only the last column. The last column is the target, and I stored as a target all. This is all target variable, and I stored it again as an array. The next step is that we need to shuffle data. Data shuffling is crucial. It is very, very important. It's not just the basic things that when we get the data, we go and build a model. Because data is ordered and sorted in any format, we always should be skeptical about the data format, about the data sorting, data order. In this particular project, the data is stored and formatted and ordered based on a date. If we don't shuffle the data and push the data in a model, during the modeling, each batch is seeing different data and stochastic gradient descent in TensorFlow might have different opinion, might have different approach to every single batch, because the first batches are totally different from the last batches because they are ordered based on a date, and in each day maybe seasonal effects, or maybe in summer people usually listen to music more than winter. So in every batches we have different user behavior, and a stochastic gradient descent might have different approach about the decreasing the loss function during the modeling. So it is very important we shuffle the data and make sure everything is evenly splitted. Shuffling the data is just in two steps. Number one is that I'm going to make a shuffle and random indices or indexes for input variable. I arrange them, and after that I reorder those indices. It means in the first section I just rearrange and reordered all the indexes, not the data, all the indexes. For example, 1, 2, 3, 4 is gonna 1, 100, 50, 67, they are reordered, they are just shuffled, just the indexes. And in the next step, I said that, okay, now we have shuffled indexes, but I need to map all those indexes to my inputs and to my targets. Now I tell them, please forget about your index. Now please be mapped to my indexes. And as you can see, I mapped the new indices order to unscaled input all my input and targets. Just because both of them are mapped to one type of ordering and shuffling, they are identical. We don't change or reorder the relationship between the input and their target, because both of them are reading from shuffled indices. It means they have the same index, but that index is in a different order from the original. Right now the data is shuffled, and we can go to the next step. Okay, next step is again very crucial step, which is for data splitting. When we are building a machine learning or deep learning model, we should split the data into the training, validation, and test data. Test data is unseen the data, and it's gonna be applied only once because it is the last step for machine learning before going to the production environment. But training and validation is just some kind of iteration process to make sure we don't have overfit or underfit. So we need to split the data set based on the data that we have. We need to have 6 steps. Number 1, we count the total number of the samples that we have. After that, we count the samples in each subset, assuming we want 80% for the training, 10% for test, and 10% for validation. So after that, we should divide the data set based on this percentage. Let me go to the code that I just showed. Okay. First step is we should find the total number of the records that we have. We have all inputs. How many rows do we have? I use shape 0. Why? Because I'm just counting number of the rows. Now we have the whole number of the data. I say, okay, for train sample count, or number of the train, number of the rows for train, it's just 80% of all data that I have. In this step, I don't say which rows. I just say how percentage, how many proportion of that data. 80% of all data that I have, which should be integer, is gonna be the training. Because 80% of all data might be a float number, I say the integer, just have the integer without decimal number. 80% is just number of the records, number of the rows for training. Validation is just 10% of the all data that I have, and whatever is left is just for the test dataset. Test dataset is that, okay, sample count, all the rows that I have. I deducted the training, those 80%, and I deducted the 10% for validation. Whatever is left is for test. Step 1, 2, and 3, we don't assign any row. We just said how many rows for training, validation, and test. In step 4, 5, and 6, now it's time to say, okay, which rows should go to each dataset. For example, in step number 4, we should say train inputs. Now we are gonna say which rows should go to the training. I said I grab that shuffled input, all the rows until just counted 0, 1, 2, 3, 4, all the rows until the train sample count. For example, if we have, just for test, if we have 1,000 rows as a total number, 80%, 800, it's just for the number for train. In this step, when we want to create a data set, it is the data set, for example. This is number 1, 2, 3. It counts all the rows until reach to 80%. This is 800. And just because the data is shuffled, we can go by order. All this data set is gonna be train. Now we have the train. Let's go for the test. For validation. And the same for the target. This is just for the input, and this is for the target. For validation, we said that, okay, from this section, this is for 800, from this section, grab this one and go to validation. So for validation, I say, from this section, go to validation. We should have 10% of this number. 10% is 100. But we shouldn't say the first 100, because the first 100 is gonna be trained. We should say 800 plus validation, so 900. From where? From the training set. So from here till 900, it's gonna be validation. And the rest, everything is rest, it's gonna be blue. Everything is left is gonna be 1000 as a test. I hope I explained well, because it's gonna be very messy, but I hope you grab the whole idea. We have the shuffled. We need to say 80% for the training, 10% for validation, 10% for the test. Now we have all the data set that we needed, input and target for each. So for training, we have 11,267 rows. For validation and test, we have 1408 and 1409. And you see the target right now is evenly split. 15% for training, 16% for validation, and 15% for the test. We expected to see 50% for each. Why? Because we have 0, 1, 0, 1. For example, here in training, just say for training, let's say we have 800 records. We have 0, 1, 0, 0, 1. We say that just 15% of them are 1. Just 15%. For tests, we have again 15%. It is here. And for validation, again, we have almost 16%. But we need to have 50%. Why? Because we are dealing with imbalanced data sets. In none of these data sets, the target is balanced. Because it makes sense. Most of the users are not gonna purchase the music twice. So it means at that time, most of the Apple music users, they didn't want to come back and renew the purchase. So it's a kind of imbalanced data set we are dealing with. If we wanted to use the traditional method for machine learning, we should have dealt with the imbalanced data set in this step. There are a bunch of ways we can use RUS, ROS, smooth, tomicling, and even more sophisticated model like isolated forest. But in TensorFlow, we have this ability to even apply the imbalanced data set on a model, and we can weight the target. Later we see during the fitting the model. I just wanted to give you hints that we are dealing with imbalanced data sets. Okay, now we are very, very familiar with the data. We split it, we shuffled and pre-processed. We are ready to go to the next step. The next step, now it's time to pre-process the data. This is the only time that we use scikit-learn. Scikit-learn is very wonderful tool for traditional machine learning, but in TensorFlow or the deep learning, I only use the scikit-learn for scaling the data, not for building the model. I apply the standard scaler as the default scaler because I use a standard scaler, just put the data between 0 and 1 as a normal distribution. Then I fit the standard scaler only for train, and just because preventing the data leakage, I just transform validation and test input based on the scaler. I don't fit the scaler on validation and test, because in that case, the validation input and test input will see the mean and standard deviation, and we will have data leakage. Just fit on training and apply that transformation on validation and test. Now our data is very scaled and it is ready to build the model. Now it's time to build a model. For building the model, the first step is that we should know we are using TensorFlow. And unlikely to the traditional machine learning model, we have a bunch of hyperparameters. And based on the project, depending on what kind of project you are dealing with, if you are dealing with image pre-processing, audio pre-processing, object detection, classification, regression, you might have different strategies. In this project, just because we are dealing with the classification metrics, we will have some hyperparameters that we need to set them. The first thing is that I need to import TensorFlow libraries. This is the basic things that we need to do. I import TensorFlow as a TF and I use TensorFlow version 2.20 if I'm not mistaken. So as I said, first of all, we need to set some hyperparameters that we have. The hyperparameters that I'm gonna use is that the input size that we have. This is just the number of the features that we have. Number of the features, how many features that we have in an Excel file or in the input, number of the features. Output size is just 1. Why? Because we only need 0 or 1. That's it. We don't need too many labels. Hidden layer or the neuron. For neuron, I say number of the neuron, I would like to have 15. It means when I'm going to make a dense model, in a hidden layer, I'm going to have 1, 2, 3, 4 till 50 neuron. How many layers I'm gonna make, they are hidden layer. How many I make the hidden layer, all of them will have 50 neuron. And drop rate is just for dealing with overfitting. I put 30%. What does drop rate means? During the fitting the model, I will explain. But drop rate means, okay, in every epoch, in every time that the model is seeing the whole data, after that, based on a loss function or the differences between the target and what model predicted, model is gonna do back propagation and update the weights and again forward propagation, backward, forward. This process is gonna be done based on a number of the epoch. This is another hyperparameters. It's gonna be done. But during the process, I randomly turn off 30% of these neurons in all the layers that I have, just 30%, to just help the model to prevent overfitting. By turning off 30% of neurons, I help model to not memorizing the data. Try to learn data and not memorize the past or relationship between the neurons. Because this dropout rate is gonna be applied randomly, so the model needs to learn the relationship between the data. And it's not gonna just memorize the relationship or the network, how the layers and neurons are connected to each other. These are just 4 hyperparameters that we set in this stage. In the next stage, I'm gonna create the sequence model. So TensorFlow cross is gonna be here. First step, in the first layer, I put one hidden layer that we put 50 as the neuron. And the activation is reload. Reload and ton are one of the best activation function for the hidden layer. I use reload because it is very modern compared to the ton. And kernel regularization is another regularization technique for overfitting. I put very, very small number for L2 regularization. Why I put L2 and not L1? Because L1 can change the probability of the neuron to 0. It means if I put L1, I'm turning off some neurons, but I don't want to do that. Why? Because I have drop rate. If I applied L1 and drop out, most of the time I'm turning off the neurons. So I use L2 to reduce very, very small number or a small effect for that weight, but not turn it off because I'm using dropout. So this is my first layer. After that, I apply the dropout. Again, I apply another layer and I apply another. And this is my last layer. My last layer, I use sigmoid. Why? Because I'm dealing with the binary, 0 or 1. If I have the classification with many labels instead of sigmoid, I use softmax. However, even in this project, we can use softmax, but I prefer to go with the sigmoid. Now it's time to use the optimizer. So we know the loss function. The loss function is just decreasing the number of the errors between the target and what model predicts. But we should say how we are gonna reach to this process or this goal. This is what optimizer can do, and TensorFlow has a compile method or function to use. I use Adam. Adam is both adaptive and using momentum. Momentum means we are gonna push the model to go to the global minimum with a good force. It's not so fast, it's not so slow. It's a gonna good push to the down. And I use RMSP or RMSP prompt, and to tell the model, okay, if you want to see the learning rate for each step, don't use all the previous steps. Just use the recent one. So in that case, the model can understand the recent networks instead of reading all the previous steps. In that case, the model during the gradient descent is a bit stable. Combination of momentum, pushing the data, and memorizing better the previous layer is just a good combination, and this combination is being called Adam. So I use this optimizer. The loss function is binary cross entropy because I have 0 or 1, and the metric is just the accuracy. I know it's not the balanced data. We shouldn't go with accuracy, we should go with recall or precision. But just because during the fitting the model, I'm gonna deal with the imbalanced data set. So in that case, we will have accuracy, and accuracy in that case matters. So I go with the accuracy. Now it's time to set 2 more hyperparameters. These hyperparameters is gonna be about the batch. You see the training numbers, what, 11,000 or 14,000? If we push 14,000 to the model without any batch, at one batch, our weight is gonna be updated only once, because the weight is only updated during the back propagation. So I go with mini batch. Instead of putting the all data, I go with the mini batch. Every single batch, the model gets some random data, go with forward propagation, calculate the loss, back propagation, and update the weight. If we go with the mini batch, we let the models to update the weights more. So batch size is 100. So if we have, for example, 10,000, let's go, for example, if you have 10,000 rows, a training, if batch size is 100, it means we will have 100 times we are updating the weight, and it is very good for models. An epoch is 200. It means this process is gonna be replied 200 times. In epoch number 1, the first batch, the first 100 goes, update the weight, second, update the weight, and this process is gonna be done to all 10,000 data is being read by model. If it is done, the epoch 1 is done. Now epoch number 2. We will repeat this process 200 times. And this is why deep learning is so wonderful compared to the traditional model, because you can imagine how many times model is reading the data and find the correct pattern and relationship between the data. So we set 2 more hyperparameters. We can go to the next step. In the next step, I'm gonna set 1 more hyperparameter. This is early stopping. Early stopping is very important when we have batches and too much epoch. Early stopping means, okay, the training, let's say this is, oh, it is so bad. Let's say this is a loss, and this is number of the epoch. The training, we expect the loss function during the training goes down to here. But for validation, it goes down till here, and all of a sudden it goes up. Here, the process should stop. Why? Because after that, we are going up. The loss, instead of decreasing, it is increasing. We should stop the process because after this process, we have overfit. But how we can let the model knows when they should stop? This is early stopping. Early stopping is said during the reading the epoch, not batch, just the epoch, because the loss function, the loss number, is gonna be calculated only after 1 epoch, not the batch. Batch is only for updating the weight, but we have 200 as an epoch, so we calculate loss function 200 times. During this loss validation and loss calculation, let's say the training, just for a number, the training loss is 1 and the validation is 1. The training is 0.9. The validation is 95. That's good because we are comparing based on its previous number. In the next step, we will have 80. We will have 92. You can ignore the training because training is not important. This section is important for validation. In the next step, we will have 90. But all of a sudden, in next epoch, we will have 93. This is the red flag for model, and it said, oh, you have to decrease. Why here you increased? This is early stopping comes to play and say stop the model. We put patience as a 2. This 2 means, okay, this is the first time, that's okay. I can be patient for twice. In the next, the model goes again 92. Again, that's fine because 92 is less than this number. But all of a sudden, it jumped to 925. Again, the model said, oh, this is another one. And we reach to the patient. So this is the final number. Because this is the last one that we reached. So putting the earliest stop is very, very important. If we put the earliest stop, we can make sure we never see overfit. You can set the patience as a 10, 1. 1 is default, but I put 2 because 2 means, okay, for first one it might be noise, but if it happens again, definitely this is overfitting. But it depends on your project and the type of the data. Okay, this is just the earlier stopping, so we put 2 as the argument for earlier stopping. Now everything is ready, patience is 2, and we set for patience for validation loss, not training loss. And the restore base weights true. It means if we reach to the best one as the last patience, save it. This is the final validation loss for us. Now everything is ready. We set all the hyperparameters and we are ready to train the model. If we want to train the model, as I said, we are dealing with imbalanced data set. Now this is the time that we need to deal with imbalanced data set. For example, right now in training, we have 2 labels, 1 and 0. If you remember, 15% are just 1 and 80% are 0 for training. So here we should let models know that these numbers are 80% more important than this one. This is 15% important. We weight the labels here. We should let models know about it. Otherwise, the imbalanced data goes to the model, and definitely accuracy is always be inclined to the higher number of the labels. But we said the lower number, we have 1, this is 15%, but it is 80% more important than the 0. Why? Because their number is so low. It means they are more important. This is just weighting the imbalanced data set. We don't have this capacity for scikit-learn because scikit-learn is for traditional, and as I said, in traditional ML algorithm, we need to deal with imbalanced data set before doing any pre-processing or fitting the model. So here we should let models know that we are gonna deal with this condition. And as you can see, I defined a class and I grab the unique labels that we have. We have just 1 or 0. And after that, I compute the class weight. I said the class weight should be the balance, and I apply and save it as a class weight. Now 1 has 85% weight and 0 has 15% weight. In the next, I fit the model. I push the train input that we shuffled, we pre-processed, and we scaled it. This is the input, the target for the train. The same for validation input and validation target. And the class weight is here. And I said, okay, the class weight, let's go capture that class weight. The 1 is more important. The epoch, we set it to 200. Batch size is 100. Callback is just the earliest stopping that we set for patience as a 2. And verbose is 2. Verbose means how the Python is going to display the process. You can put 0. If you put 0, you don't see anything after running the code because you're not going to display it. If you put the verbose 1, Python shows everything. But if you put verbose 2, you only see the most important. As you see, just because I put early stopping as a 2, we put 200 epoch, but in epoch number 5, we stop. Let's see why we stop here. The validation loss was 58. The next one we decreased. But here we increased 0.54. This is 1 flag. And again in next one, again the loss function increased. So we set the 2 patients for early stopping and model stopped, 78% for validation, and 77% for training. It's not bad, just for the first iteration. We can just modify the different hyperparameters. We can add layers. We can change number of the neurons or all the hyperparameters that we have. We can try different combination to find the best percentage based on the project that we are dealing with. So let's say we are happy with this percentage and with this accuracy. Now it's time to test the model. Testing the model is the last step. If you test the model, after that, change the hyperparameter tuning, you need to test the model again. Because test the model means we are happy with everything. Now let's see how model is working on scene data. So here we use the model evaluate method in TensorFlow and push the test input and test target, apply the model on that, and we see the test accuracy is 38%, which is so amazing. And it shows we not only have overfit, but also we don't have underfit. And hopefully we make a good model for Apple Music. So right now they can use this model to predict their customer behavior to make sure how possible is the customer coming back to renew their subscription. In this project, I just showed you how TensorFlow can be useful and how easy it is compared to the traditional method with scikit-learn for building the model. I hope you enjoyed this video. If you want to download the file, please go to the link in the description for this video to go to my GitHub and download the material. See you soon in the next project.